So, looking at number 10, I meant to change the equations, and I forgot to. So you might notice that those are the exact same equations as number 8. What I want to remind you is this. When we talk about graphing an inverse, there's two ideas at play. One is that the ordered pairs just switch. So if my original graph had the ordered pair 1, 4, then my inverse graph is merely a flipping of that ordered pair to 4, 1. And so just for the sake of time, I'm going to jump over to my work in 8 where I already talked about graphing those points. And I'm going to just talk through flipping a few of those points. We start off at -5, 0, which means we're going to be down here at 0, -5. We then go to -3, -2, so that's going to be -2, -3. -1, 0 goes to 0, -1, and we can start to see, let me think for a second. Yeah. We can start to see that parabola shape opening to the side. We can keep that going. Up here we go to 0, 2.5, so I'm going to go to 2.5, 0, and we finish out right there. And that is going to be our inverse of our parabola. If I jump over to B, I can do the same thing. I start at 0, 1, so I'm going to switch over to 1, 0. And then I'm kind of, next point over here, I'm at 1, 3, which means I'm going to be at 3, 1. And then 2, 5 means I'm at 5, 2. And we kind of see where we're headed here, and that V shape just continues. And the key with both of these that I want us to remember is that graphically, our inverses are always going to be a reflection about the line y equals x. If I draw that y equals x line in, we can see that reflection between those points. I can do the same with this graph over here. And we see that constant reflection between those 2 points about that line y equals x. And that's what you need to remember about graphing your inverse functions, is quickly you can see if they have that reflection about the line y equals x. And then you know they are inverses of each other.